Hello, in this lesson, we're going to apply definition of differentiability or derivative on trig functions. And of course, in the process, we have two very important identity that I wish to review with you. And the first one is the limit of, theta approaching 0, that's what's in the textbook of sine theta divided by theta. Of course, this can come in, and that limit equals to 1. Okay, we're going to explain, and the proof of these will be saved for another time. And a similar version of this limit is, it could be x, right? It could be x as x approaching 0. And the other identity is that its limit, okay, as this limit is cosine theta minus 1 divided by theta. And this limit equals to 0. And of course, another version of it would be, instead of using theta, you would use x. Okay, same thing. Okay, if you observe these two examples, right? As theta approaching 0, sine theta is approaching 0. Theta as theta approaching 0. So it's a 0 divided by 0 situation, but the limit is equals to 1, right? And the other one is as theta approaching 0, sine theta approaching 1. The numerator is approaching 0, denominator approaching 0, but the ratio has the limit of 0. Okay, to understand these, we can look at the two functions. Okay, we can look at the two functions. One of them is sine x over x, and the curve is like this. So when x is approaching 0, of course, the domain of this function is all real numbers but 0, right? All real numbers but 0. If I show you the view, right, say -10 to 10, right? It could really go from -infinity to +infinity except 0. So at 0, this function is undefined. It's undefined. So this software, I'm going to put a little dot here because we were not able to do this in class. And the software doesn't show us a circle. So this function, as you can see, as theta approaching 0 or x is approaching 0. Okay, so I'm going to put these on the side. Okay, put these on the side. So we just look at, they're the same thing, really. X and theta, there's just a placeholder. But anyway, so you look at this function, and sine x over x is the entire curve from -infinity to +infinity with domain. X cannot be 0. We need to understand that. But the limit, okay, the limit is we look at the neighborhood of 0. Okay, the limit is that we look at the neighborhood when x is approaching 0. So this little interval, okay, it's a small interval. So that limit and the sine x over x are different. Okay, so this just means when x approaching 0, sine x over x is approaching 1, applying the definition of limit. And you can see, indeed, when x is approaching 0, from either side, approaching from smaller than 0 or approaching 0 from larger than 0, and both limit, equals to 1. Okay, so we need to understand that these two are different. Okay, without limit or with limit. Okay, common mistake. Common mistake is that some people just write it down, something like this. Okay, this is a very bad mistake. This is a very, very bad mistake, because without the limit in front of it, it doesn't equal to 1. In fact, sine x over x is the entire curve from negative infinity to positive infinity, and it doesn't equal to 1. Okay, so that was a common mistake. Let's look at the other curve. Okay, sine x minus 1 divided by x, right? So this is the curve. Look like this. This is the curve. Okay. It goes in both directions, and of course, x cannot be 0, right? X cannot be 0. And the domain is any real number except 0. All right. So that's the curve. It goes in both directions indefinitively, but in the neighborhood of 0, when we take limits, okay, when we take limits, then the limit of this function is 0. So approaching 0, or approaching 0 from left of 0, or approaching 0 from right of 0, that limit is the same, equals to 0. Okay, we need to understand this. The proof of these identities, I'm going to save it for another time if necessary, where I have time. But understanding this limit, okay, because these two limits are very, very useful, very, very useful. And one of the applications of these two identities happens for when we apply the definition of differentiability on trig functions. Is that, for example, how do we find the derivative? Of course, you guys know the derivative of sine is a cosine. That is not a problem. But we also want you to know how this is being proved, which is a cosine x, right? So we're going to prove that in this lesson. Okay, so now we have a function f of x equals to sine x. How is this proved, right? So we're going to find the derivative. We're going to find the derivative of it. Okay, so we want to find the derivative of sine function. There. Okay. By definition. Okay, here's how it's been done. The proof goes like this. Definition. So we have f of x equals sine x, right? And f of x, and of course we need these two identities for our application, right? The first one, I'm going to put it at the bottom, okay? And the next one are these. Okay. All right, so let's do the proof. F of x. So now since the function is sine, right? We know f of x is sine, f of x plus h. X plus h is going to be sine of x plus h. Okay, then what do we do? Right, we're gonna plug in, and we also know sine x plus h equals to sine x cosine h minus cosine of h plus cosine x sine of h. That's the formula, okay? And then we're going to plug this in. We're going to plug this in, okay? So please have a piece of paper with you, right? Paper, pencil, and derive it along my side. So we're going to replace f of x plus h, which is sine of x plus h, subtracting sine, f of x, of course, is sine x. Okay, then what do we do? Algebraically, this can be done by you. Okay, so let's do it together. Let's do it together. It's also about whether we can apply limit law. Okay, whether we can apply limit law. And obviously now we cannot because we have it dividing by 0. The same trick, right? So we're gonna bring this minus sine x to join with this piece. Okay, so sine x can be factored out. You see, sine x can be factored out. And now we are going to, on this piece, sine x is a common factor. So it's factored out. So this is minus 1. And there's a sine x here, right? And this piece, right? This piece, we're going to separate. It's the same technique. And divided by h. And of course, all of it is going to be in the bracket. We cannot separate the limits, not yet. Okay, and then what do we do? Right, now you can see we can apply the limit right here. We can apply this piece, right, on h. Let's just remove these theta thing, right? Keep it simple. On this piece, that individual limit exists at 0. On this piece, we're going to separate cosine x and put it like this. So we have 4 individual limits, and they all exist, right? Sine x has nothing to do with h. And cosine h minus 1 divided by h, this piece we can apply this limit. And sine h over h as h approaching 0, that limit is 1, so we can apply that limit. So this way, we can apply limit law. We can apply limit law. And the limit law is applied as follows. Okay, so the limit, okay, apply to sine x. Wait. Okay, put it here. And put it here, here, and there. So we're applying limit law here. But we apply limit law here by, after we check each individual limit exists. So in the end, we get to practice using these 2 limits, very important limits. And then this piece equals to sine of x. And that piece is 0. So multiply by 0, anything times 0 stays 0, right? And limit of cosine x has nothing to do with h. This is a cosine x. And limit of sine of h over h as h approaching 0, that's 1. In the end, we got the limit. We got that limit equals to cosine x. That's how the derivative of sine is cosine is being proved. Okay, so how about for the derivative of a cosine? Because for all 6 trig functions, if we know the derivative of sine, cosine, and the rest of them, we can just apply product quotient rule. Okay, most of them using quotient rule, we can resolve those. We can find those limits, right? So if you do this deriving, I really believe that if you do all of these deriving, it would really enhance your algebraic skill. Okay, so let's look at let's see how we're going to apply definition of derivative to prove, right, the derivative of cosine, and what are we getting? Okay, now we're going to find the derivative, right? We're going to find derivative of cosine. Derivative of a cosine. So now instead of sine, we're finding derivative of cosine. Applying the same definition. And what is it? Be found. Okay. Similar, very similar. Over here, we're getting cosine x plus h. Oops. Lowercase h. Oops. Divided by, sorry, I deleted something. Okay. I'll just put it back in. H approaching 0 minus cosine x divided by h. Okay. And now we got to apply the formula for cosine a plus b. Okay. So we have a formula cosine, which you learned in trigonometry, that equals to cosine A multiply cosine B, not C, sorry. Subtracting sine A, oops, minus sine of capital A, sine of capital B. Okay. Now we're going to apply the formula on cosine x plus h. You can see how valuable these deriving can be for us to enhance our, algebraic skill, review the trigonometry. So now we got cosine x, cosine h, cosine h, subtracting sine x, sine of h, and minus cosine x. Okay, and same trick. We're really going to apply the same trick. We're going to bring minus cosine x closer to another term that has cosine x as well. Therefore, we can factor it out, right? And now we're going to organize our terms. Separate this piece, okay, by subtracting divided by h, right? Cosine x is factored out. Cosine x is factored out. We're going to put it outside. And the next one, we'll put a sine x outside. And all of these, as you can see, is just some simple algebraic manipulation, right? And we have 4 individual limits to see. And now each individual limit exists. This limit exists, has nothing to do with h, and this limit we can apply that piece and this one once again, right? And so we can apply these limits individually. So we're going to put this limit individually, can remove the bracket. Individually, we're applying limit law. And what do we get in the end? In the end, we are getting as h approaching 0, cosine x is the same as cosine x, treated as a constant. But the next limit in the product, that's 0. We get to apply this limit, so right, that's a 0. 0 times anything is 0. Subtracting sine x, the limit of sine x is sine x as h approaching 0 because there's no h in sine. And this piece, same, is 1. So in the end, we get the derivative of cosine is a negative sign. So we got the answer. The derivative of cosine is sine, right? So now we have these two identities, right? The derivative of sine, I'm going to just change the form, right? Is a cosine. And the derivative of cosine is a negative sign. So let's derive the derivative for tangent, cotangent, secant, cosecant, right? So these four, once you've gone through this step, what's the value of it? You get to review trigonometry, algebra, basic skills, okay? And you also find, there's you get ideas how to do your homework. Okay, you can see I haven't done any homework for you because I expect you guys to do it. Okay, but to see the proof would really help us to enhance our skills. So next, we want to take a derivative of a tangent x. Okay, how do we do that? We get to apply quotient rule because tangent x equals to sine x over cosine x. Apply quotient rule. Do we remember quotient rule? Okay, so quotient rule goes like this. We have proved it. Derivative, right? F over g equals to g squared, derivative of f multiply g, subtracting f multiply g prime. Okay, or another version of it, g squared, stay the same. So this will be the derivative of f and put a g in front. You can see why we put a g in front, right? Because that avoids those confusion. Okay, derivative of g, that's the derivative of g with respect to x. Okay, so we get to apply the quotient rule. Okay, g squared, that's cosine. So cosine squared of x. On the numerator, g, right? G is in the denominator, so g is cosine x. Multiply the derivative of f. The derivative of f is sine x. The derivative of sine is the cosine. Subtracting. Now f stayed the same. F is sine. multiply the derivative of g. G is a denominator. The derivative of cosine is negative sign. Now, simplify. Okay, so cosine x times cosine x is cosine square x. Negative sine x times negative sine x, that's going to be plus sine square x. Sine square x. And sine square x plus cosine square x is equal to 1. So this piece is 1 over cosine square x. And cosine square x, you know the relationship between cosine and secant. So this is secant square of, right? So we derive the derivative of tangent is the same as secant squared. And then certainly I would encourage you guys to derive for cotangent, right? For cotangent. So for cotangent, right, instead of tangent as a cotangent, x, and the cotangent is cosine over sine. And we apply quotient rule. You can see you don't really have to memorize all these formulas. Once you let it go through your hands, then you can do it all by yourself, right? So use the quotient rule. So this is sine square of x. And the top is derivative of cosine is negative sign. And multiply the denominator g, that's the sine x. Right? Subtracting f cosine x stay the same. Multiply the derivative of sine, which is g, right? That's cosine. This way we got a negative of sine squared. And we got minus cosine squared of x. And factored out the negative sign, right? Factored out the negative sign. So we insert parentheses here. And that is minus 1 on the top. So this is going to be negative 1. So that equals to negative cosecant squared of x, right? So now we got the derivative of cotangent is equals to negative cosecant squared, right? So we have, and you don't have to memorize them. And the derivative of tangent is right here, right? No need to memorize because you have to derive them all. You have to derive them all. So last but not least, what is the derivative of secant cosecant, right? The derivative of cosecant. What is the formula? Right? What is the formula? If we know the relationship between cosecant and sine, we know that this is 1 over sine x, right? And we're going to apply a quotient rule again. Quotient rule, and here what's on the top? Top f is 1, right? Denominator is sine. So you have sine square of x. And the derivative 1 is 0. The derivative of sine is cosine x. subtracting 1 times the derivative of c. C is sine of x, right? Derivative sine is cosine. Oops. So this part is 0. And 0 times anything is 0. So we have a negative sign in front of it. Okay, so this is part is gone. So -1, we can omit it, right? So this is one form of cosecant. You can see the formula in the textbook usually doesn't give you this form. It give us another form, right? But this one is also, it can also be useful. Okay, so and there's multiple forms for the derivative of cosecant, right? And you can write it as, right, sine square x is sine x times sine x, right? And cosine x divided by sine x, that's cotangent. So you can also write it down. So this will be a really good review. So there's going to be negative, okay? Cotangent x, right? Because cosine divided by sine is cotangent. And we have an extra sign, 1 over sine, so that 1 over sine is cosecant, right? So we got one more formula for derivative of cosecant, which is, there are 2 forms. Remember, there's another form, right? But the form you see in the textbook is this one. But you can also derive it when you need it. Okay, sometimes this form may be useful, And last but not least is what the derivative of secant. It's going to be very similar. Now it's secant. Okay, and secant is 1 over cosine. 1 over cosine. Right here, cosine x. And quotient rule, right? Cosine squared of x, and the top is f, right? It's f is 1, g is cosine x. The derivative of 1 is 0, so 0 times anything. So the derivative of cosine is negative sine. Well, this part is going to be 0. Subtracting 1 times the derivative of cosine is negative sine. So by doing this, you guys, we should be pretty familiar with these formula. Product rule, quotient rule. Simplify. Then you can see this piece is 0. 0, we don't have to write it down. -1 times negative sine x. The top is just simply sine x. So this is another form for derivative of secant. But if you like to write it in the form of the textbook, you can separate it. You can separate these one more time, because cosine x squared is a cosine times cosine x. And sine x over cosine x, that makes tangent x. So tangent x multiply 1 over, cosine x as a secant. Okay, so that way you get the other formula. So by this time, you have all the formulas. So you only just have to, you really just have to know the derivative of sine and derivative of cosine. And the rest, it takes you just less than a minute to derive. So you never have to memorize them. Okay, so this is the value of deriving these identities. You're deriving these derivatives by yourself. And of course, you see all these formulas. So instead of trying to memorize those formulas, just get down to paper, pencil, and derive them. Then you get them all. You get them all, get them all you needed. Applying these 2 limits, we actually cover them in class. That should be sufficient, but I would do some more examples for you to help you review by covering more examples from your homework. So that will be for another lesson. Thank you for watching.